In this video, I'm going to solve an exam question of June 2022, where we will have to calculate the length of an arc of a circle. The question explains that this is a profile of a wall light and we need to calculate the length of this curved edge. We need to understand that the curved edge is the arc of a sector that belongs to this circle that has a radius of 150 millimeters. Half of the sector has an angle of 75 degrees, but if we consider both parts, the angle is going to be 150 degrees. So we need to calculate the length of an arc that is part of a sector that has 150 degrees and a radius of 150 millimeters. These are the formulas that are included in the booklet that you will get the day of the exam. Here you have the formula of the length of an arc of a circle. The formula is the radius times the angle. But you need to be aware that this angle is in radians, not in degrees. 1 radian is the angle that we get when the length of the arc is the radius. If we want to convert degrees into radians, we need to multiply the angle in degrees by pi over 180. I'm going to solve this using 2 different methods. In this first method, I will use the formula that uses radians. So the first step will be converting 150 degrees into radians. 150 times pi over 180 is 2.618 radians. So the length of this arc is going to be the radius times the angle in radians. The radius is 150 millimeters and the angle in radians is 2.618, and this is 392.7 millimeters. The question says, state your answer to 3 significant figures. So the answer is going to be 393 millimeters. Now I'm going to use a different method where we will be using degrees instead of radians. You can use this method if you don't remember how to convert degrees into radians. The circumference of a circle, or the perimeter, is 2 pi r. The length of the arc represents a fraction of the total perimeter of the circle. To find out this fraction, we need to divide the angle of the arc, in this case 150 degrees, by 360 degrees, because a full circle is 360 degrees, and times it by the full perimeter of the circle. So the length of the arc is going to be 150 over 360 times 2 times pi times the radius, which is 150 millimeters, and this is 392.7 millimeters. And if we round this number to 3 significant figures, the answer is 393 millimeters.